In this video, we're going to focus on the 10 fundamental problem from chapter 3. The material for a 50 millimeter long specimen has a stress gain diagram shown. If P equals 100 kilonewtons, we are to determine the elongation of the specimen. We are provided with a graph that shows a 450 megapascal yield strength, which means under this curve of the triangle, it will not permanently deform but only temporary. This also means that we can use a Hooke's law. I also provided an extra graph to show you how materials deform. Anyways, let's start this problem. Our first step is to calculate the stress that this specimen undergoes. To do this, we simply use this equation that we have used in the past videos, which is your stress equals your P, your force, divided by your area. And we have a force of 100 kilonewtons, which we want to convert to newtons. We just simply multiply times 10 to the 3. And we would divide by your area, which is pi over 4 times, we can see over here, we have a 20 millimeter diameter. So we convert this to meters by simply dividing by 1,000, and your radius is squared. Your diameter has to be squared. We enter this into a calculator and we get 318.31 megapascals. Now we know that the yield stress is less than the yield strength, which is going to be right about there. So that means we can apply the Hooke's law. Now let's calculate the modulus of elasticity, which simply we can do by using this equation, which is modulus of elasticity equals your yield strength divided by your yield strain. We have 450 megapascals. We convert to pascals by multiplying times 10 to the 6. This is going to be pascal. And our strain, you can simply see here, is 0.00225. Now simply enter this into a calculator and we get 200 gigapascals. Now we calculate the strain for our material, for our deformation or stress, and this is simply calculating the strain, which is your stress divided by your modulus of elasticity, and this is equal to 318.31 megapascals. We divide this by 200 times 10 to the 9 to convert it to pascals. And to provide homogeneous units, we're going to go ahead and convert the megapascals to pascals by multiplying times 10 to the 6. There's going to be pascal over pascal, cancel out, which has no unit. So we enter it into a calculator and we get 0.001592. Now we have everything that we need to determine the elongation of the specimen. And the equation for this is simply equal to your strain times your length. For the strain, we have 0.001592 multiplied times the length, which is 50 millimeters. And we get 0.0796 millimeters. And this is our final answer. If you thought this video was helpful, don't forget to smash the like button and subscribe.